Okay, so let's begin the discussion. In last session, we have discussed about multi-level queue scheduling. We have talked about the benefits and drawbacks of multi-level queue scheduling. In multi-level queue scheduling, the very prominent drawback or well-known drawback is there are chances of starvation because the scheduler start picking the processes from the higher level of the priority queue. So if a process is waiting in the lower level of priority queue, and if the upper levels are not getting empty for a very long period of time, there are considerable chances of starvation. So to solve such kind of problem, there is another CPU scheduling has been introduced, that is multi-level feedback queue. So what happens in this type of scheduling, as I have depicted in this diagram, there are multi-level of queues based on their priority. So let's say this is Q0, Q1, Q2, Q3 and so on. There are different levels. Different level of queue can have different types of algorithm. So as I have mentioned, the level 0 queue where the priority 0 processes are arriving, it is incorporating round robin scheduling and the time quantum is, let's say, 8 time unit. And the level 1 queue where priority 1 processes are arriving are also incorporating round robin scheduling and the time quantum is 16 here. And the lower level of the queues is incorporating or using first come first serve. Okay, so there are certain points which we need to discuss about multi-level feedback queue. So let's discuss those important points. Now here I have mentioned that this particular algorithm is it is the combination of, let's say, uh, like round robin priority scheduling and feedback scheduling. So by combining different algorithms all together, we form or design multi-level feedback queue scheduling. It allows the system to adjust priority. So it adjusts the priority. In this, when a process arrives, it arrives in the top level of queue. Okay. And later on, the priority of the process gets changes. And the level of queue will also be changed. So multiple queues are there as it was already in the multi-level queue and they will have different priority. The highest priority queue has the shortest time quantum. So this is very important point you need to note down. The highest priority queue will have short time quantum. Okay. So in the highest priority queue, the process can consume limited number of CPU cycles. And if the process finishes within the time quantum, it will be removed from the high level of queue. If a process does not finish during the time quantum, then it will be shifted to the lower level of the priority queue. Okay. So the lowest priority queue has the longest time quantum. Lowest priority queue has the longest time quantum. And the highest priority queue has the shortest time quantum. The process enters the highest priority queue initially. So this is very important. Every process enters initially at the highest priority queue and then moves to the next lower priority queue if it executes its time quantum or if it exceeds its time quantum. So when a process arriving in the highest priority queue, if it is not able to finish its execution within the allocated time quantum, then it will be shifted to the lower level of the queue. If a process completes its execution before its time quantum expires, the process will be removed from the queue, right? If a process waits for a certain time, let's say a process is waiting at lower level of the queue for a certain duration of time, its priority gets improving. And this concept we consider as aging. So let me write this we consider as aging. Okay, so please do remember this. And once the priority will start increasing, the lower level process or low priority process start getting shifted to the upper level, right? That's why we are saying there is dynamic priority. So higher priority process may get shifted to the lower level of the priority queue, and lower priority process may get shifted to the higher level of priority queue, right? So this algorithm allows short processes to be executed quickly. So if a process is short, require less CPU cycles, it will be quickly executed and finish its lifetime. And long processes to run without being blocked by short processes. So if a process is having long cycle, long requirement, although it will go down, but after some point in time, it will start getting higher priority and getting shifted to the upper level, right? Multi-level feedback queue is a useful algorithm for managing resources with a dynamic system with varying priority and workload. So in a system, if there are dynamic priority has been implemented and variety of workload is there, then such kind of scheduling is suitable, right? So there are certain benefits which we have already discussed indirectly. Efficient use of CPU or resources. So this algorithm try to utilize resources effectively, efficiently. It provide fair CPU time to each and every process, whether it is higher priority or low priority. It try to maintain the priority in such a manner so that every process gets almost equal time to get executed. It maintains the dynamic priority. So higher priority processes, if it is taking more time, will be shifted to the lower level. A process which is waiting at a lower level of priority queue, after some point in time, start increasing the priority. Okay, preventing starvation. So this is the very important thing, very desirable benefit. And this algorithm is very flexible. The algorithm is flexible. It can be customized to suit the requirement of different system by adjusting the number of queues, priority, and time quantum. So all these things can be adjusted, and this algorithm is very flexible in nature. Okay, so let me come back to the diagram. So please do remember, initially every process arrives at the highest level of the priority queue. If that process require more CPU cycle, then it gets shifted to the lower level and so on. Okay, so this is the multi-level feedback queue scheduling. Thank you everyone. I hope this is clear to you. So I'm closing this session. See you in the next session.